Alright, so we are here with question 6 of the November 2018 South African CAP syllabus matric mathematics exam, and this is paper 2. Now question 6 here we can see this is a question on trigonometry. Alright, so let's just get right into it. It says consider that the function f of x equals negative 2 tan 3 over 2x. So let's write that down. F of x equals negative 2 times the tangent of 3 over 2x. Alright, so that's what we have so far. Let's just maybe run through all the questions and see what we'll need to answer the rest of all the questions, and then maybe do a little summary at the top here. Okay, so we need a period. Okay, so for the period, let's just do that. And let's write some more of the information we'll need right here. So we know if we have a basic equation of y equals a sine b x plus p plus q. So those are all the things that can be included in a trigonometric equation. So a, this is our amplitude. This is our amplitude, right? And the amplitude is just, if you have a graph like this, the amplitude is how far does it go up and down, right? So like this has a bigger amplitude than this, and that has a smaller amplitude. So that is amplitude, and that's the a value. The b value has to do with the period. So again, let's have a look at this. So the period of this function is this many degrees, right? That's how long it takes before it starts repeating. So again and again. So every time it repeats, the period is this many degrees. That is your period. Your period. Okay. So your b has to do with the period. It isn't your period, but we can say, so we have to know the original period of the sine function. So we know the period of sine, of cosine, and tangent, and let's remember to put the angles, theta, theta, theta. Okay, so for a sine graph, the period, normal period is 360. And for cos, it's also 360, and for tan, it's 180. So those are your standard periods, right? The period of each of these. Now, the b value tells you what to divide that period by, right? So we're going to say the period of the function, the period equals, and let's say, or let's put the equals down below, equals the original period, so that's these figures, right? 360 or 180. Original period divided by b. That'll give you your period for your specific function. So we're just going to divide the original period by b to get our new period for this specific function. Now the p value here, I'm going to change it to minus p just so we can see that we have to focus on the sign here. I'm going to make that minus p. So this value is your horizontal shift. So shift left or right. Let's just put shift here. So that's your left or right shift. So if we had x minus 30, then we'd shift it 30 degrees to the right. And if we had x plus 40, we'd shift it 40 degrees to the left. So we need to take account of the negatives. That's why I put the negative, just to show it's the opposite side movement. And then q, that's your vertical shift. Your vertical shift. Okay, so that's all the information we need to know about the standard sine, cos, or tan graphs. And it's the same for all of them. Except for tan, we don't really call it amplitude in a sense. Maybe we do. It depends on what you actually taught. But the amplitude just tells you how far the graph spreads or stretches up and down. Right? So for tan, we can think about it like this. So that's your normal tan graph, and let's say you make the a 2, so you stretch it up by 2. So it stretches up a little bit like that. So that is your amplitude. All right. So we'll need that. Period, amplitude, general solution. Okay, so for general solution, let's just cover the idea quickly. Let's say you've got some graph like this, and it keeps going forever. So a general solution would be, let's say we picked, well, let's say the graph looked like this. Let's just draw a straight line through here, and like maybe a vertical line. So now let's say we want to solve for if x equals this value. Let's say that value is like 10, right? So if we go up and we read off this value here, so that value will repeat, right? We can see as we're going along. Let's change a color for this one. Let's change a color, and So as we go along here, we'll see we cut the graph multiple times. So every time we touch it, so that'll be at 10, right? At this value, again, we'll have the same. At this, we'll have the same again, the same again, the same again. So your general solution will tell you something like x equals 10 plus, and when it repeats. So that'll be the period, right? So over here, it'll be exactly the same. So whatever that period is, that'll be repetition. So that is what general solution means. It means you get some value, but you repeat it as often as the period. All right, what else do we need to know? Draw the graph. Okay, so this is how we draw the graph as well. We look at the amplitude, the period, the shift, vertical shift, horizontal shift. Okay. Use your graphs to determine which values f of x will be greater than 2. That's fine. We can just read that off the graph. And transformation. Okay, so this is pretty much all we need to know, right? So let me keep this on here. Let me keep this on here and then answer the questions just next to this. Okay, so we'll keep that as our sort of reference. And now let's get into the questions. So let's do another color for the questions. We'll start with 6.1 right down here. Question 6.1, write down the period of f. So we said the period has to do with this b value here, right? So we said the period is your original period, which in this case for tan, the original period was 180. So we're going to say that's 180 divided by the b value. And what is our b value in this case? Our b value is 3 over 2, right? You can see that's the one we're talking about, the one in front of the x. So 180 divided by b, and that'll give us, what is 180 times 2, 360 divided by 320 degrees. So 120 degrees is the period of our function. All right, pretty straightforward so far. Let's look at 6.2. 6.2. Okay, so 6.2. Let's read the question. The point A, which is t and 2, I'm just going to write that down so long. The point A has coordinates of t and 2, so your x value and your y value. And it lies on the graph, so we know this is on this graph that we have. Determine the general solution of t. Okay, so our equation, or our graph, negative 2 tan 3 over 2x, let me just write that down again. F of x equals negative 2 tan 3 over 2x. So we can just plot the point, or plug the point A into our equation. So we know the y value is going to be 2, and the x value, negative 2 tan 3 over 2, and then x. And we know our x value is t, right? So I'm just going to write the t. Let's just put brackets around this so we know that. Alright, now we need to solve for t. So what we want to do for a general solution, we want to get a single trigonometric function, so either just sin or just cos or just tan of some angle equals a number. So the first thing I want to do, I want to get rid of this value in front of you. So I'm going to divide both sides by negative 2, which gives negative 1 on the left hand side, and the right hand side we've just got tan of some angle. And that angle for us is 3 over 2t. Right, so we've got a single trigonometric function of an angle equals a number. So now to solve for this number, we can just say, well, the inverse, not the inverse, the arctan, right? Or as we call it in calculator language, shift tan of this value, right? But we're going to ignore the negative, and I'll get to that in a moment, equals the angle. And the angle is 3 over 2t. All right. So why do we ignore the negative? Well, we've got our cos diagram. Maybe let's just draw that in here somewhere as well. Let's do that over here. So let's say this is our cos diagram. So what does the cos diagram tell us? Let's just write in CAST for cost. Oh, sorry for the screen flickering. I don't know what's going on there. Okay, cost. So that's, oops. So we've got 180 degrees, right? If we start at 0 here, or 360, or any multiple of 360, we go 90, 180, 270, 360. So this way is positive. So 180, if we go to this quadrant, we get 180 plus some acute angle, and this quadrant would be 180 minus some acute angle. This one would be 360 minus some acute angle. Alright, so your cos diagram tells you what is positive in which quadrant. So cos is positive in the fourth quadrant, all things are positive in the first quadrant, sin is positive in the second, and tan in the third. Alright, so we're going to use that. We're going to use that. So we see here we've got arctan of 1 equals 3 over 2. So if you type arctan of 1 in your calculator, you'll get 45, right? 45 degrees. So we're going to say that's our reference angle. That's our reference angle. So actually, let's just call it a reference angle. And then we're going to see, but tan of some angle was negative. So in which quadrant is tan negative? Well, tan is negative in the second and the fourth quadrant. But for tan, we only need to use one of those. So you can choose which one you want to use. I'm going to choose quadrant number 2. And you can choose quadrant number 4, no problem. So quadrant number 2, let's just have a look again. This quadrant is 180 minus. So we're going to say our angle that we work with is 3 over 2t, right? So 3 over 2t, our angle, equals 180 minus 45 in the second quadrant. So 180 minus 45 is 135. And then we're going to say, but it's a general solution, so it has to repeat. Now, how often does it repeat? Well, tan repeats every 180 degrees, right? And we can do 180 any number of times, right? 180 to the left as much as we want, or to the right as much as we want. If we just look at our graph again, this is what it will look like, right? Infinitely many of these. So if this is our value we're looking for, 180 degrees to the right, we'll find that. Another 180, we'll find that. So this is what the k means. The k has to be an integer because we only move a whole number of times to the right or to the left. If you move a whole number to the left, it's a negative whole number is an integer, right? So all of these are integers, and that's the idea of why we have the general solution, or what it means to have a general solution. It repeats, right? So it just solves the general case, not just any specific case, but all general cases. All right, but we want t, not 3 over 2t. So what do? We just divide everything by 3 over 2, which will give us t equals, and then 135 divided by 3 over 2. So 135 times 2 is 270, divided by 3 gives us 90. So it's 90 degrees plus, and now 180 divided by 3 over 2. We already did that calculation over here. That's 120. So the new period is now 120 degrees. And remember to put k as an element of the integers. Right, so that's our solution for t, our general solution. So just a quick look. That will mean if this is our function with our tangents in between, that if we look at what 90 degrees is tan of, tan of 90, or t, if t is 90 degrees, we'll have 90 degrees here, and then 120 degrees further, so this will be at 210, right? So if that was 90, then at 210, and if we go to the left, so 90 minus 120, what is 90 minus 120? Well, let's open a calculator because we're going to use that anyway just now. So 90 minus 120, not times, 90 minus 120 is negative 30. So we know this is going to be negative 30, this value here, right? Negative 30. So we see that's a general solution. It doesn't matter how far you go, every time you'll get a value that's 120 degrees left or right of 90. And you can keep going to the left, and you can keep going to the right. That is our general solution. All right. That was question 6.2. Now 6.3, on the grid provided in the answer book, draw the graph of f for the interval from x equals negative 120 to 180 and show all asymptotes, intercepts to the axes and endpoints, etc. Okay, I don't have a grid here, but what I can do, I can maybe just do the background and change that into a grid. Yeah, that seems pretty plausible. Now let's draw a grid. Let's draw a grid to work on. So I think, yeah, let's draw it over here at the bottom. Let's do that. That should be sufficient, and maybe that. Okay, let's hope I chose wisely. And we were going to go from negative 120 to positive 180, right? From negative 120 to positive 180. Okay, so let's say this value here is negative 120, and then I'm just doing 30 degrees. So this would be negative 90, negative 60, negative 30. Yeah, I should probably get rid of this one, or just move it over. Whoa. Just move this over here. Okay, that makes sense. That makes a lot of sense. Negative 30, 0. then positive 30, 60, 90, 120, 150, and 180. All right. And let's do 1, 2, and -1, -2. Great. Okay, so we've drawn our grid. Now what do we have to do? Draw the graph of f. Okay, so we need to draw our graph, which is this one here. F of x equals -2 tan 3/2x. Now the easiest way to do this, I think, is, well, actually I don't know which one is the easiest. But if you don't want to learn the theory of all of this, what are the A, the B, the P, and the Q, how they affect the graph, the original graph, and shifting the points, you can just type in your calculator the values, right, to find your answers. So let's actually just do that and show what that would look like. Okay, so our equation is -2 times tan of, let's do another bracket, 3/2, 3/2, and then times that by x. Okay, so what is our x? Let's start with -120 as our first value, -120. And we get, I'll put a dot in there. Okay, so we get 0. So -2 tan 3/2x is 0. Okay, what color will we use for this? Let's go with, keep on going with green for this question. So -120, 0. Now we do -90. Right, so instead of -120, we have -90. So that'll give us -2. So at -90, we have -2. And we just keep going. You just keep plugging in these values. Then -60. And what does that give us? An error, right? Why? This is where there is a tangent. So let's draw in a tangent. And let's use this. At 60 degrees, we have a tangent. Right? And now we know, since it's 120 the period, if we go 120 to the right, there'll be another tangent at 60. Another 120 to the right, at 180 there will be another tangent. Alright, so we've drawn in our tangents, but when you get to 60, you would see the error again. So let's maybe just type positive 60, just to see if we go positive 60, there should be an error again, right? Because that's another tangent. Alright, back to our work. -30 is the next value that we're testing, and that gives us +2. So -30 we have +2. Then what do you think 0 will be? 0 should be 0 again, right? Make that 0, we'll get 0. And again, what do you think 30 will be? Right? We've got our graph here, and it'll just keep on repeating like that. So at 30 it'll be -2 again. Unless we can use the calculator just to make sure. So we'll put in +30, and we should get -2, exactly. 60 we'll get an error again. At 90 we'll have 2 again. 120 we'll have 0, and 150 we'll have -2 again. Okay, fantastic. So here we can just draw our graph. Ooh, I'm still on the dotted lines. Let me switch back to standard. Okay, there's our graph. And here it is again. So this just keeps going. This just keeps repeating all the way like that. Alright. So there we have our points. Great. Now we've drawn our graph and everything is fine. Let's see what's next. Use the graph to determine the values for which, let me just switch colors here and write, this is question 6.4. So we're going to use our graph to determine for which values of x will the f of x be greater or equal to 2 in the interval we've drawn here. So greater or equal to 2, so we want to check over here, draw a line there. I'm going to say where, for which values of x will the graph be above 2, right? So, okay, and we also want to limit it to our domain that we drew in, so only in this area. Now, which things do we want to check? So we can see in this interval here, in this interval, is the graph below or above 2? It's below 2, right? It's below 2. So for that interval, we're not interested. That doesn't work. Next one we want to check is between negative 60 and 0. Well, negative 60 and 0, that's not going to quite do it because part of it's above, part of it's below. So wherever it crosses the value of 2, wherever it intersects this line, so there we want to check, right? So we want to check here, this interval, where does it cross 2 again? Here. So those are intervals we want to check. So between negative 60 and negative 30, what happens here? Yes, here the graph is above, right? Above the line 2. So far we have from negative 60 to negative 30. That's one part of what we want. Then between negative 30, so let's make a right correction mark here. Between negative 30 and 0, no, it's below 2, right? So this doesn't work. And over here it doesn't work either, right? Also below 2. It's even below 0. From 0 to 60, that doesn't work. Then from 60 to 90, yes, we can see here the graph is above 2. So from 60 to 90, it works again. And then from 90 all the way there, the graph keeps on being below 2. So we're not interested in that either. So this will be our answer. Right, x between negative 60 and negative 30. So between negative 60 and negative 30. Or, what is the other one? Between 60 and 90. Right, between 60 and 90. And now let's just make sure about the equal signs. Should it be strictly greater than, or should it include the endpoints? Now let's see. Greater or equal to 2. So let's make sure. So at negative 30, it's greater or equal to 2 because it's equal to 2. What about at negative 60? At negative 60, we have an asymptote. Let me just draw that line a little bit longer. Right. This asymptote keeps on going forever. So this graph gets closer and closer, but it never touches. So it never touches this line negative 60. So the graph does not exist at negative 60. So at negative 60 will be not included. That's not included because the graph doesn't exist there. Right? Anything bigger than negative 60 but less than or equal to negative 30. Because at negative 30 it is equal to 2 and that's fine. Same over here. 60 is an asymptote, the graph does not exist there so it cannot be included. 90 on the other hand, 90, the graph is exactly equal to 2 and we can have equal to 2 so it is included. So that is then our answer. For all these x values, the graph will be greater or equal to 2. Great. Now question 6.5 to finish up question 6. Describe the transformation of the graph of f, or f, to form the graph of g of x. Okay, so let's just write on f of x first. F of x again was negative 2 tan 3 over 2 x. Okay, now g of x equals negative 2 tan, and then we've got 3 over 2 x plus 60. Okay, so probably one mistake that some people will make. They just see this plus 60 here and immediately think, like this p, if we've got x plus 60, it means 60 degrees to the left, right? What's the difference? So that would be correct. If we had negative 2 tan x plus 60, that would mean the graph shifts 60 units to the left. But what's the difference? We don't have x, we've got 3 over 2x. 3 over 2x. So how can we transform this so we've got x plus something in the bracket where we know what to do? Correct, we can take out 3 over 2 as a common factor, right? So from here, so for g, we can rewrite that as negative 2 tan, and then let's take out a 3 over 2 as a common factor. So 3 over 2, and what's left? X plus, and what's 60 divided by 3 over 2? That's 40, right? 60 divided by 3 over 2 is 40. Okay, so now we do have the nice answer. Negative 2 tan, well actually this is perfect just like this. So we've got the x plus 40 part, which means 40 units to the left. So the graph has shifted 40 units to the left. So that is the description of the transformation we're looking for. So important, pay attention to this. you want to transform it so that you've got the x plus 40 or x minus something, so that you can know that's the horizontal shift. Right? You've got something else, so 3 over 2x or 5x or something. You first want to factor out the coefficient of x, and what's left, that'll be your shift. Okay, great, because this 3 over 2 has more to do with the period. That's more the b value. Great, so that's it for question 6 on trigonometry and trigonometric graphs, and I'll see you again shortly for question 7.